is Amanda Boole-Chafin. I work at the Lane Community Technology Center in Hamilton, Ohio. Welcome to part 2 of our spring series. In this series, we'll be creating our very own custom light-up acrylic sign completely from scratch. In the last video, I showed you how to wire and program the lights. In our second video, I'll walk you through the process of designing a 3D printed base to hold your electronics and support your sign. Finally, in the last video, I'll teach you how to design, cut, and etch the laser-cut acrylic sign. That means that now is a really good time to subscribe to our channel to make sure you don't miss the upcoming parts of the project. If this project looks familiar to you, that's because I did a brief overview of this project last year. This video series breaks each part of that project down into its constituent parts. This might also look familiar if you watched our previous video about how to light up a 3D printed snowman base. We used the same components, except this time we're only using one NeoPixel. It's a good reminder that these skills and components are transferable to different projects. Today we'll be building a casing for the electronics that we prepared last time. So to do that, we need to know how big those components are. Use a pair of digital calipers or a ruler to carefully measure the components that you coated and soldered last time, including any wires that are sticking out and any cords that you will use to connect your device to power. It might help to sketch a rough diagram or write down the measurements. This sketch does not have to look pretty. It just has to give you a basic idea of the shape and size of your electronics. Now it's time to log into TinkerCAD.com. TinkerCAD is free, web-based, drag-and-drop computer-aided design software that lets you create simple 3D objects. If you don't already have an account, create a personal account now by choosing Join Now, and then create a personal account. It's going to give you different options, okay? If you already have an account, you're just going to want to sign in. You could do that here or here. So I'm going to go ahead and sign in with my personal account. Okay, and once you're signed in, everyone's dashboard is going to look a little different, okay? But what you're going to want to do now is you're going to go to this Create New Design. So we're going to click that. Okay, and here is what the TinkerCAD workspace looks like, okay? Just to give you a brief little tour, anytime you click this TinkerCAD button here, it'll take you back to your dashboard. Over here, you have your different options for view. Zoom and all that right here. Up along the top, you have some different tools that will be available to you when an item is selected. Over here, you have your work plane. We're going to use that quite a bit. And then your shapes are all down here, okay? And then here is where you choose your grid, and you also have the snap grid, which we'll get into a little later. So it's a pretty well-designed workspace. Now, before we start, it's important to realize that you don't have to reinvent the wheel. I searched Thingiverse for the term Gemma, and I found something that I want to use. It is right here, I saved it for you. It's the Large Computer Volume Control Knob by 8-Bit Logic. It's right here, and don't worry, I will link it in the description. You don't have to use this, but I'm going to be using this as a base for my design, okay? Now, if you scroll down, you can see here that this item is offered under a Creative Commons license, and if you click it, it'll actually show you what you're allowed to do. So we're allowed to share it, we're allowed to adapt it. There are some terms. If we're going to redistribute it, we have to distribute it under the same license, but I'm not going to redistribute it, so I don't have to worry about that. What we do have to do is we have to give appropriate credit and indicate if changes were made, and we are doing that. So I told you already that I'm going to be changing it, and also that this is by someone named 8-Bit Logic on Thingiverse. Now that we know that we're allowed to use the file and we have properly credited the author of the file, we're going to go to here to Thing Files. And then we are just going to download these pieces. Alright, so now we're going to go back to TinkerCAD and we're going to import them. So we're going to hit this import button right here. We're going to choose a file. I'm going to go here to download. We are going to upload these one by one. I'm not going to change this from millimeters to inches yet. I'm just going to hit import. Okay, and if you are an American like me, it's probably a good time to go down here to Edit Grid and change your units to inches. And then I'm going to change my width here to about 9 and my length by about 8. Because that's roughly the size of my build plate on my printer. And there we go. Okay, so now that we have all 3 components loaded into TinkerCAD, now's a good time to take a look at our measurements and see if there's anything that we need to change. So for my design, I knew I didn't want the angled piece, so I clicked and pressed the delete key. So that's this piece right here. See how it has this angle? I don't really need that. So I'm going to go ahead and click on it, and then I'm going to just hit the delete key. Easy peasy, now it's gone. Okay, so now if I look at this base plate here, I'm going to click here and I can see the dimensions, and it is 2.913 inches. And then if I look at the cover here, the cap, I can see that it's about 2.559. And then if I want to see how tall it is, I can click there and I can see that it's about 1.063 inches tall. Now when I check that against my diagram, I see that this should give me plenty of room for my electronics, so I don't really need to change anything in terms of size. So that's great. Now the first problem I see is that this cap part has this rod in it that I don't need or want. We are going to have to get rid of that. And then I also see that we're missing some things that we need. We need a slot to hold the acrylic sign part and emit light. We need a cradle to keep the electronics secure. And we need a hole for the USB cord. These are the things that we're going to have to add. Now deleting the rod is actually pretty straightforward. What you're going to do is you're going to drag this, so let's move this to the middle just so we can see it, the cap. And right up here, remember I mentioned this work plane was going to become important? This is when we're going to use it. So we're going to click it and drag it, and we're going to drag it right here onto that plane. This is the inside of the cap, the bottom inside. So now you can see we have this orange space here. This is our new work plane. Anything we drag is going to drag on top of here instead of this older surface, the blue surface down there. So now we're actually going to use it. We're going to drag this cylinder-shaped hole down here, roughly to the center of our cap. And you can see it placed it right there on top of our new work plane. So now we're going to change this. We're going to make it about 2.38 inches, okay, in diameter. And we're also going to take this sides. We're going to move it way up. Segments too, because we want to smooth those edges. So now I'm going to hold down Shift and I'm going to select my cap. So now both the hole and the cap are selected, but the base is not. And now we're going to align these. So I'm going to click this Align tool, and I want to align the hole to the cap. So I'm going to click the cap, and now I'm going to click these to the X and the Y axis there, so that it's going to fit right in the center. I'm not going to use this vertical axis because remember I want it to sit on top of this plane. And if I aligned it to one of these nodes, it would no longer sit on that plane. So now that I have that, what I'm going to do is I'm going to click off of it. And I'm just going to look, make sure my hole goes above my cap there, and it does, and that nothing's sticking out below, and it's not. So that's good. So now I'm going to click on my hole, hold down Shift, click on my cap. They're both selected, and I'm going to hit this group button here. And there you go. We have deleted the rod. Easy peasy, you are left with a smooth cap. If you're enjoying this video and you want more like it, don't forget to like and subscribe, or even leave a comment. I try to answer all questions in a timely manner. You can also give us a shout out on Facebook. It helps us spread the word about all the cool resources and services we offer. Now we need a part that's going to cradle our electronics. So we're going to drag our work plane back to the original work plane. We're going to move our cap aside for now, and we're going to bring over our base because this is what we're going to be focusing on. Now this is where our measurements come in handy. We know that our largest part, our NeoPixel, is about 1.5 inches in diameter, but we've got some wires sticking out a little bit, so let's go ahead and build in some extra space, some tolerance, just to make sure everything will fit. So let's call that 1.5 inch NeoPixel 1.55 inches for wiggle room. Now put your work plane down on top of your base. And now let's go ahead and plop down a hole and make it 1.55 inches in diameter. And again, we're going to drag up these sides and segments to make it all nice and smooth. So now we're going to center align these two pieces. So remember, hold down Shift and click both of them. hit your align button, click your base, and center on the X and Y. So now we know that the hole inside our cap is 2.38 inches in diameter. We know that because we just carved it out in order to get rid of that rod. So in keeping with the idea of adding in tolerances or wiggle room, let's go ahead and drag down a cylinder that's about 2.3 inches in diameter. So slightly smaller than the space that we know is inside our cap. We're going to center align it to the base. So now what we're going to do is we're going to look at our diagram. We need to determine how tall our electronic components are. Mine stands at about 0.6 inches at the tallest point. I want to make the walls of that cradle high enough to contain it securely though, so I'm going to go with 0.75 or maybe 0.7 inches. So yeah, let's do 0.7. So make your cylinder 0.7 inches tall. So now we're going to drop our cylinder one notch. We're going to change snap grid here to 1/64th. And we're going to drop our cylinder so it's 1/64th of an inch below. And now we're going to group all three of these objects. We can actually move this down just a touch. As long as it's sticking up over the rim of our cylinder, that's fine. So now hold down Shift, select all three of these objects, and then group. So now let's make sure that our cap still fits. We're going to move our work plane over here to the top of our base. So we're just going to click on our work plane. We're going to drag it down right here. And that's going to adjust it. And now what we're going to do is we're going to flip our cap 180 degrees. So once that's at 180, we're going to kind of move that here over top of it. We're going to align these. So we're going to select both parts here, click our alignment tool, and we're going to align it on both of these axes. Again, we're going to click our cap. We're going to hit D as in dog or drop. And that's going to drop that right there to the top. So now we can pull our work plane back. We don't need that right there for the moment. We are going to click on our cap and we're going to turn it transparent. So we're going to click where it says solid there and turn it transparent. And then we're going to zoom in and we're going to kind of examine it to make sure that none of these walls are clipping. So see how you can see that there's a little bit of space there in between? That's kind of what I want. And I want to make sure that there's some space up here too at the top. So now that I made sure that there's space here and space here, I know we're good. So we can go ahead and turn that solid again. We're just trying to make sure that the pieces are going to fit together. So the next thing we need to do is we need to create a channel, right? We're going to click here on our cap and we're going to duplicate it. And then we're going to raise our duplicate copy up. We're going to go to this one. We're going to make it a hole. We're going to change our snap grid to 1/64th of an inch. We're going to click on our cap. We're going to hit this little, see this little up arrow button here? We're going to take it down one notch. Maybe 2 notches. Oh, you know what? Let me undo that. Here's why. So let's put our work plane here. And now let's drop it down 1 notch. And now we're going to click that invisible cap and we're going to click our base, holding down Shift so that we can select them both. And we're going to click this group button. And what that's going to do is that's going to create a channel right here for this to slip into. So now I'm going to move our work plane down here, put it in the middle there in that channel. And now when we hit D to drop, it's going to drop it right into place. So you can see how it's already starting to fit together. Okay, so now we need to make a slot for the USB cord. So to do that, we're going to take our work plane tool, and let's just put it back its usual spot there. We're going to take our cap, and we're going to move it up, out of the way, in the same plane there, okay? Just out of the way for now. So now what we're going to do, we're going to take a box, pull it down. So I recommend making your USB slot at least 0.7 inches in both directions. That way you have some wiggle room in case you want to use different size cords. But of course, your size is going to depend on your cord. So you will have those measurements, right? Let's go ahead and fill in those dimensions. And let's drag this here. What we're going to do is we're going to put our work plane here in the bottom of our base. We're going to drop that to it. Alright, and we're going to pull this out. I'm going to raise it a step so I won't have it cutting in Now that I've got that, I'm going to duplicate it. Group 1. Move my work plane back. Drop. And group. Now I have a nice little channel. If I raise that out of the way, you can see it's not cutting in. It's a nice little channel. Now when you raise the cap up, you see that this one looks like a little bit of a window, and that's going to make it a little hard to print. So I'm just going to click on it, I'm going to ungroup, and now I'm going to actually take that, I'm going to make it just a little taller, my hole here, from the bottom. So I'm going to grab it from the bottom, and I'm going to pull it downwards, so it's past that little lip, and then I'm going to regroup. So now that little ledge is gone, so it should fit pretty well. If I drop it down, fits real snugly into place and gives your USB cord a place to go. Now it's time to make a sign. We'll be designing the sign next time, but for this time you do need to make one decision about the sign. Size. I decided to make mine about 4 inches by 3.5 inches, and I stuck a tab at the bottom that was about 3/8 of an inch tall and 2.5 inches wide. The sign will need to be just over 1/8 of an inch thick, since that is the size of the acrylic that we're working with. So let's mock that sign up in TinkerCAD. So I'm going to start by moving my work plane. Then I'm going to select everything, and I'm just going to move it out of my way a little bit. Now I'm going to pull a box down, and the first thing I'm going to worry about is making it 1/8 of an inch. So I'm going to go over here to Snap Grid, going to make it 1/8 of an inch. Grab this and drag it down to 1/8 of an inch. There we go. Now if I edit my snap again to 1/64, click on it, and I pull it up just 1 notch. Now I know I have some wiggle room, or some tolerance there, just in case something's not exactly perfect with the acrylic. So I think I said 4 inches tall and 3.5 wide. It's looking right. So now I'm going to duplicate that piece, and let's shift it downward here. And I think I said I needed this to be about 3/8 of an inch. So let's arrange that. Now we're going to take our work plane and we're going to put that right here on that edge. We're going to drop it. That's the D key. Now we're going to select both of these, and we're going to hit our alignment tool, and we're going to center that up. Drag this edge inward until the tab is about 2.5 inches wide. Now let's center along that bottom edge. Okay, good. Now group. Okay, so now we're going to take our sign and we are going to convert it into a hole. And the reason we're going to do that is so that later we have a slot for our sign to fit into. So the first thing I'm going to do is I'm going to click on our sign, and I'm going to duplicate it. Then I'm going to rotate it 90 degrees. Okay, I'm going to drag this over here. I'm going to pull my work plane over on top of my cap, hit the D key to drop it, pull my work plane back. Now I'm going to click on my sign, I'm going to hold down Shift and click on my cap, and I'm going to click my Align tool. I'm going to click on my cap again, and I'm going to center align my sign to my cap. Now I'm going to just sink my sign into my cap. I'm going to change my sign into a hole. Hold down Shift and click my cap, and group. So now we have a nice slot that our sign can fit into. Alright, so now we just have to position the design for printing. So to do this, all we're going to do is we are going to move our cap away, and we're going to turn it 180, and we're going to drop it to the work plane. We want all of our pieces here to be dropped to the work plane. This we don't necessarily need, but we can keep it for now just in case we need to make changes later. So now when we 3D print it, we won't need very many supports because we're printing mostly straight up and down here. Okay, so when you are finished, what you're going to do is you're going to email your design to us at the Tech Center. If you're using your own 3D printer, now's the time to choose your materials and print settings. If you're located in Butler County, Ohio, and you're printing your design here at the Tech Center, email us your print request at techcenter@lanepl.org. You're going to send us your STL file as an attachment. Requests are printed on a first-come, first-served basis, and filament supplies are limited. So in the body of the email, please include your requested filament color. For this design, I recommend a black filament. So what you're going to do is you're going to hit export here and STL. And then that is the file. It should be in your downloads folder. That's the file that you're just going to email as an attachment to the Tech Center email. Now remove any support material with pliers or wire cutters and make sure your electronics fit securely within your design. Next time, we'll design, etch, and cut the acrylic sign. For now, pat yourself on the back for a job well done. If you're located near Hamilton, Ohio, and you'd like to learn more about laser cutting, 3D printing, or programming microcontrollers, give us a call at 513-785-2727 or email us at techcenter@lanepl.org. For hours and location information, check out our website at lanepl.org.